On June 20, 1944, a human-made object pierced the boundary of Earth's atmosphere for the very first time. It was a V-2 ballistic missile. We reached the stars by building a weapon designed to strike targets hundreds of miles away. Today, the motivation to leave our atmosphere is measured in profit. Look at this scale chart. Down here is the total value of the entire global economy in 2019, roughly $142 trillion. Looming over it is the estimated value of Asteroid 16 Psyche, $10,000 quadrillion. The path from early astronomy to a multi-quadrillion-dollar corporate space race required centuries of friction. Back in the 1600s, scientists like Galileo looked through polished lenses, observed moons orbiting Jupiter, and realized the Earth was not the center of everything. The Holy Inquisition responded by actively hunting and condemning the astronomers who challenged their approved view of the cosmos. To physically leave the planet, we first had to understand the mechanics of gravity holding us down. In 1915, Albert Einstein published his theory of general relativity, merging the physics of motion with spacetime. He proved that gravity dictates how objects move through the universe. With the physics mapped out, engineers in Nazi Germany applied these principles to military hardware. Hermann Oberth and his team developed the V-2, a guided ballistic missile relying on liquid fuel propulsion, to exit the atmosphere before dropping explosives on Allied cities. The technology required to break Earth's gravitational pull emerged directly from the Second World War. The drive to reach space originated in the urgent, militarized effort to kill from higher and faster than ever before. With the Axis defeated, the United States and the Soviet Union absorbed these rocketry advancements and turned them against each other. In October 1957, the Soviets struck a massive psychological blow. They launched a 58-centimeter metal sphere called Sputnik 1 into orbit, proving they could fly objects directly over American airspace at 28,000 kilometers per hour. The rush to establish orbital dominance meant taking lethal risks. A month later, the Soviets launched a stray dog named Laika aboard Sputnik 2. They told the world she survived for nearly a week. In reality, the capsule overheated almost immediately, and Laika died in orbit, a fact the Soviet Union hid for over 4 decades. Human testing followed the exact same high-risk trajectory. When Yuri Gagarin became the first person to orbit the Earth in 1961, his descent pushed the human body to extreme limits. Re-entering the atmosphere, Gagarin absorbed 8 times the force of normal gravity before ejecting from his capsule mid-air and falling safely to a Russian farm. The pressure on the United States to respond led directly to disaster. Rushing to meet a presidential deadline to reach the moon, NASA engineers skipped critical safety redundancies. During a routine launch rehearsal in 1967, a stray spark in the pure oxygen environment of the Apollo 1 cabin ignited a fire, instantly killing 3 astronauts. The space agencies adapted, redesigned the hardware, and pushed forward. By July 1969, Neil Armstrong and Buzz Aldrin navigated the lunar module Eagle over the uneven, powdery surface of the moon, touching down with only 25 seconds of fuel left. Walking on the moon proved the United States possessed superior engineering, effectively winning the geopolitical standoff. But it also proved that the lunar surface was largely barren. The real tactical and economic value lay closer to home, prompting both nations to stop sending humans to the moon and focus entirely on dominating Earth's orbit. Living in orbit requires enduring constant biological degradation. Here is a simulated look at a human spine in space.
Without the constant downward pull of gravity compressing the body, the vertebrae literally separate. An astronaut's spine stretches, causing them to grow up to 3% taller, a condition that leads to painful compression injuries upon returning to Earth. The damage compounds the longer a crew stays aloft. Astronauts confined to tight quarters for 6 months lose up to a quarter of their muscle mass in their calves and backs. Beyond the bone and muscle loss, the severe isolation of long-duration missions routinely induces deep psychological depression. By 1986, the American public believed traveling to space was as routine as taking a commercial flight. That perception shattered on January 28th, when the Space Shuttle Challenger broke apart 73 seconds after liftoff, killing all 7 crew members and halting human spaceflight for years. NASA shifted its primary focus to robotics. Probes like Voyager 1 and 2, which require no life support systems and never need a return trip, were sent to map the deep solar system, eventually crossing the boundary of the heliopause and venturing into interstellar space entirely. In 1991, international space exploration lost one of its main financial pillars. President Mikhail Gorbachev announced the dissolution of the Soviet Union, instantly ending their state-funded space programs and freezing the massive infrastructure that had launched the first satellite into the cosmos. The lethal risks of navigating a vacuum, combined with the billions of dollars required to design vehicles that can survive it, became too much for governments to justify on their own. As federal budgets tightened, an entirely new class of investors saw an opening to claim the stars. In the early 2000s, tech entrepreneurs stepped into the void left by shrinking state programs. Elon Musk founded SpaceX with a very specific utilitarian goal: aggressively reduce the price of accessing orbit to make commercial spaceflight viable. The turning point arrived with the Falcon 9. Instead of letting multi-million-dollar engines burn up in the atmosphere after a single use, engineers designed the first stage booster to fall back to Earth, reignite, and land vertically on a designated pad. Reusing rockets slashed production costs. Other billionaires quickly followed suit. Amazon founder Jeff Bezos launched Blue Origin, personally riding his own rocket to the edge of space and publicly thanking his retail customers for funding the trip, turning orbital access into private industry. If you track where this new corporate infrastructure is pointing, you find Asteroid 16 Psyche. Both NASA and private companies are already monitoring its trajectory. Unlike comets mostly made of ice and dust, Psyche is composed of highly concentrated minerals. This chart visualizes the asteroid's potential economic yield, representing a staggering valuation of $10,000 quadrillion. Looking closer at this breakdown, the rock contains massive deposits of iron, nickel, platinum, and gold. Mining this would completely eclipse the current economy of Earth. Alongside this rush for orbital resources, pure scientific discovery continues. Instruments like the Hubble and James Webb Space Telescopes are suspended in the dark, absorbing infrared light to photograph the formation of the very first galaxies born after the Big Bang. We have to decide what the cosmos will look like in the next century. Will private companies use their wealth to colonize the solar system and ensure humanity's survival? Or are they quietly claiming the universe's resources to solidify a monopoly? Let me know your thoughts in the comments, and subscribe to catch our next breakdown on the legal loopholes of space law.